Okay, so today we'll start with a third lesson on properties of the angles, and it is proving. So proofs involve a conjunction. What is a conjunction? So when we make a statement we believe to be true, this is the conjunction. So using the strategy that we use to proofs is that with a limited number of truths, we can make the statement. And each statement will have a reasoning, a justification. Why are we doing this? What is the logic behind that we are saying? So now, the assumption that we have here is that when we have the two parallel lines, corresponding angles either are equal to each other, and vertical opposite angles are equal, and angles created by a straight line are supplementary. Those are the three rules that we will use to prove um, the truth about the alternated interior angles, which is alternated 4 and 5 here. So now, are they equal or not? Now, the way that we will prove it is that we will assume that those two lines are parallel to each other. So line 1 and line 2 are parallel to each other. How do we know this? The picture is telling us with those two little arrows here. So now angle 1 and angle 4 is equal to plus angle 4 is equal to 180 degrees, a supplementary angle. And then angle 3 and angle 4 are equal to each other, a supplementary angle. Angle 2 and angle 5 are equals to 180 supplementary angles. And the vertically opposite, so corresponding angles, angle 1 and angle 3 is equal to each other. And therefore, angle 3 and angle 2 are equal to each other as vertically opposite angles or supplementary angles, and angle 5 is equal to angle 4. It's a bit overwhelming when you see this, but the way that we are proving it is like this. So angle 1 and angle 3 equal to each other. So angle 1 and angle 3 is equal to each other. And those are the three reasonings. Vertical opposite angles, so vertically opposite. Opposite angles. And then angle 1 and angle 4 are angle 3 and angle 4 are equals to 180, so as a straight supplementary angle. So angle 3 plus angle 4 equals to 180 as supplementary angles. And angle 3 and angle 2 are equal to each other as the corresponding angles. So then, therefore, angle 4 and angle 5 is equal to each other. Well, let's move to another example here. Given that the two lines LM and OP are parallel to each other, prove that triangle LMO, LMN, and PON have three pairs of angles equal to each other. So if those two are parallel to each other, two lines are parallel to each other, then the line, I will just draw it with a different color. then the line LO is the transversal line, So then on the transversal line between those two parallel lines here, we will have this angle L, equals to angle O as the alternated um, interior angles. Now let's change the color and then take a look again at the two lines and a second transversal line being the line PM. So now the line PM is the transversal line of the two parallel lines. So angle M and angle P are equal to each other as the alternated interior angles as well. So, and the third pair of angle, you can use the sum of inside angles in a triangle is equal to 180, which means that this is equal to the sum of the two, which is equal to the sum of the two, or you can say that those two angles are opposite angles. So then we prove that in the triangle LMN and PON, we have three pairs of equal angles. Let's take a look now at this. The triangle FOX is a isosceles triangle. Remember what we said about the isosceles triangle is a triangle that has two sides equal and parallel to each other. No, equal to each other. So this side here, we can say that FO is equal to FX, which means that angle FXO is equal to angle FOX. So those two angles are equal to each other. So now, given this is an isosceles and angle FOX is equal to FRS. So then we will have this angle here equal to this angle here. Okay. Whatever is equal, I will make it as in one color. Now the angle F is the same. Okay, it doesn't changes. What we are trying to prove here is that SR is parallel to XO. Now, in those two lines, SR and XO, the transversal line FQRO, this line here, is creating two alternated interior angles. So therefore, you can say that the line SR is parallel to XO. So when the two angles, remember what we said on the prior lesson, that we can use those angles to prove that the lines are parallel. The two alternated interior angles are between two lines, but we don't know if they are parallel or not, and a transversal line. If they are equal to each other, then the two lines are parallel to each other. And then again, it's the same triangle, and now we will prove that PQ is parallel to SR, knowing that FXO is equal to FPQ. So this angle here, let's change the color. This angle here is equal to this angle here. So now we will take a look at those two lines. If we extend those two lines here, then the fx becomes a transversal line. And those two angles are the exterior angle, alternated angles, which tells us that if they are equal to each other, then PQ is parallel to XO, and it is the same time parallel to SR, because those two are equal to each other as well. Since this is equal, from the previous example, this was equal, and then this was equal. So we can even draw a further conclusion here, saying that triangle FPQ is isosceles triangle. Triangle FSR is isosceles triangle as well. Two sides are equal to each other, and two base angles are equal to each other. And then the triangle FXO is parallel, is isosceles as well. And all those angles are equal. And on all those three triangles, FPQ, FSR, and FXO, we have three sets of angles that are equal to each other, because the vertex angle, angle F, is the same to all three triangles, and the base angles are equal to each other, since those three lines, PQ, SR, and XO, are parallel to each other. So they create the isosceles triangle. Okay. Now, as the assignment, what you will see is on page 78, question 10, 8, 10, 12, 15, 16, 18, and on question 85, on page 85, question 6. This concludes the third lesson of properties of the angles. It's a bit weird, but we will go through this together in a Zoom session if you have difficulty.